In this session, let's see what is relay and contactors. In electrical circuit, both relays and contactors are switching devices. It can be differentiated by operating principle. Relays are used to switch relatively small output and current. Contactor to switch relatively large output and currents. First, let's see what is relay and operating principle. Relay is an electromagnetic switch operated by relatively small electrical current that can turn on or off a much larger electrical current. Relay can work either as switches, like turning things on and off, or as amplifier converting small currents into larger ones. Next, let's see the building diagram of relay. Relay we use to connect between the two circuits. And in this diagram, you can see the switch. This we call it as a control switch. And one control coil. And this we call it as a contacts. When you turn on the switch, the current will start flowing to the coil. And coil will generate the magnetic energy which attracts the contacts. When the contacts get connected, the current will start flowing to the load. In this relay, there is no electrical connection between the circuits. The link between the circuit is magnetic and mechanical. Next, let's see the construction of relay. In this, we'll see both mechanical and electrical side. In mechanical side, you'll get two contacts, mobile contact and fixed contacts, and one coil and an armature. In electrical side, you'll get three terminals. One is normally open, common and normally closed. When the signal is not energized to the relay, then you'll get an output voltage at normally closed contact and common. And when signal is energized, then you'll get an output voltage at normally open and common. In this relay, it's very important to understand the normally open contact and normally closed contact. In a relay, initially, if there is no power, then in NC contact, you'll get an output voltage because of this contact connection. When you give an input, then the voltage you'll get at normally open contact. So let's see the voltage differences in this NO contact and NC contact. Suppose if you are giving a 24 volts, then initially if you are not turning on the control switch, if it is in off state, then at NO contact you will get a 0 volts. At NC contact you will get a 24 volts. When you turn on the switch, then at normally contact you will get a 24 volts and in normally closed contact you will get a 0 volts. Next, let's see the different types of relays. Relays are usually SPDT or DB-DT, single pole double throw or double pole double throw, but they can have many more sets of switch contacts. Number of contacts called as pole, and a number of position or a number of combination of the contacts is called as throw. Let's see the different types of relay. First is single pole, single throw. It means it have only one contact, that is NO contact. In this small example, you can see there is a two power source. First power source for the coil and a second power source for the circuit. In this example, I have considered one switch with lamp. Initially, the switch will be in the open contact, so that lamp will be in off state. Once you turn on the switch, then this contact will be connected and the power will start flowing and the lamp will turn on. This is a normal switch. Next, we'll see single pole double throw. In this, you will get two contacts. One is normally open contact and normally closed contact. And this type of relay will use to control the two circuits. In this example, you can see I have considered the two lamp 1 and lamp 2. Initially, without energizing the signal, because of this contact is connected, your lamp will turn on. And once you energize your signal or once you turn on your switch, then lamp 1 will turn on and lamp 2 will turn off. Means when the switch is in off state, then lamp 2 will on and lamp 1 will be in off state. Once you turn on your switch, then lamp 2 will turn off and lamp 1 will turn on. This is a combination of NO and NC contact. Next is double pole single throw. Means here you will get two contacts, two normally open contact. In this example, you can see there are two lamps, but it is connected to the normally open contacts. By using the single coil, you can control the two circuit. Once you turn on the switch, if it is S1 and S2, once you turn on the S1 switch, the current will flow in this path and the lamp 1 will turn on. And if you turn on the switch 2, then the power will flow in this direction and the lamp 2 will turn on. At the same time, you can operate both the circuit. Next is double pole double throw. Means here you will get two normally open contact and two normally closed contact. By using this, you can control 4 circuit by a single coil. Here I will name it as S1 switch and S2 switch. Lamp 1, lamp 2, lamp 3 and lamp 4. Initially, when switches are in the off state, then lamp 2 and lamp 4 will turn on because of this normally closed contact. Once you energize the signal, once you turn on your switch, then lamp 1 and lamp 3 will get on and lamp 2 and lamp 4 will be in off state. So this is double pole and double throw. Next, we'll see the advantages of relay. Relays can switch AC to DC, but transistor can only switch between the DC. Relays you can use for the switch between AC circuit to DC circuit. Relays can switch high voltages, but transistor cannot switch high voltages. Relays are better choice for switching large currents. Relays can switch many contacts at once. For example, we have seen double pole, double throw. Here we can control 4 circuits and we can increase the number of contacts in relay. Next, we'll see some disadvantages of relays. Relays are bulkier than transistor for switching small currents. Relays will take larger time than this transistor to switch between the circuits. Relays cannot switch rapidly. Transistor can switch many times per second. Relays use more power due to the current flowing through their coil. Relays require more current, so lower power transistor may be needed to switch the current for the relays coil. Means relays cannot be used in larger current and in fast or a rapid switching. Next, let's see some applications of the relay. Relay can be used in various fields like regulating, controlling and monitoring purpose. Relay can interface between the control circuits and load circuit, and relays can be used for a signal multiplication, and relays can be used to separate the direct current and alternating current circuits, means DC to AC circuit. Relays can be used to produce delaying and generating and converting the signals, and relays can use to linking the information. Next, let's see on contactors. Contactor means a relay that can handle the high power required to directly control an electrical motor or other loads. A contactor is an electrically controlled switch used for switching a power circuit similar to relay, but it switches the higher current. Next, let's see the components of contactor. It are three components: power contacts, auxiliary contacts, and contact springs. This is a symbol of contactor. Power contacts means is a main contact of the contactor or normally open contact, and is usually used to connect power load to main supply. Auxiliary contact. Auxiliary contacts are secondary switching device. These contacts are usually used for interlocks or retainers of the primary device's control circuit. Auxiliary contacts are available with either normally open or normally closed contacts. Next, let's see the construction of contactors. In this, there are main four parts. First is electromagnet. Second is spring contact. Third one is movable contact. And the fourth one is fixed contact. When the coil is energized, then the movable contacts will start moving and it will attract to the core. Then the contacts will become closed contact and the power will start flowing to the secondary circuit. When the coil is de-energized, the spring will return to the initial position and it will become open contact. Power contacts. Power contacts are the main contact of the contactor, or usually a normally open contact, and it used to connect power load to main supply. Auxiliary contacts. These contacts are secondary switching devices. These contacts are usually used to interlocks or retains the primary device circuit. Auxiliary contacts are either normally open or normally closed contacts. Next, let's see the difference between relay and contactor. Relays are used at lower load, which is below 5 kW. Contactors are used in high load, where to switch the heavy duty. Relays are control the device by open and closed contact. Contactors are repeatedly establishing and interrupting an electrical power circuit. Relays are used in control circuit only, but contactors can be used in both control and power circuit. Relays are much cheaper compared to contactor, but contactors are a bit expensive. Relays are not economically to repair. If the relay got damaged, we can't repair that relay, but contactors are designed to repair. These are some differences between the relay and contactor.